So for part A, so it's a cos theta plus alpha, so we're going to use the cos A plus B formula that I've just copied and pasted out of the formula booklet. So just setting this up, so just copy that out and incorporating the capital R. So that's the first line of workings. So go and make that equal to what we're told to make it equal to, the 10 cos theta minus 3 sin theta. Then equate coefficients. This first term here, we've got the R cos alpha equaling the 10, the bit in here in yellow. And then secondly here in orange, we're equating the sin alpha. So R sin alpha equals 3. So just make sure you can see where those two have come from. And then we can do two things to this. If we divide through, if we do equation 1 divided by 2, we get tan alpha equaling 3 over 10. Inverse tan that, we can get alpha being 16.69 to 2 dPs. And then going back to our 1 and 2, if we square both of them, we can say this squared plus this squared equals this squared plus this squared, which is this line of workings. Then factorize that, and of course sin squared alpha plus cos squared alpha equals 1. So we got r squared equaling 109, so r equals root 109. So part B. So start off by just copying out the question, and then I've just rearranged it to make it compatible for the part A. So I've just popped this bit in brackets over here. So we're now minusing open bracket, a minus sign in the middle, and then a closed bracket in the end. And then this just allows us to substitute in what we discovered in part A, where we got R being root 109 and alpha being 16.69. And of course, we're replacing theta with our ATT. So just make sure you're comfortable with that third line there. Now, in order to work out the constant A, we've got a fact, haven't we? We know the initial height of the passengers above the ground is 1 meter. So when T is 0, H is 1. So substitute that in, H being 1, T being 0. And then working that through, we get A being 11. So our final equation is H equals 11. Take away all of that stuff. So part B, part 2. Find the maximum height of the passengers above the ground. Now this bit's a bit trickier perhaps. Go back to our final answer for B part 1. We want to maximize the height. Now whenever we cos something, the values are going to be between -1 and +1. Now if we're wanting to maximize H, we want to be minusing the biggest minus possible. So we can go and find a particular value of T that will make cos bracket equal to -1. That's going to maximize H when we've got 11 minus root 109 times -1. Okay, so minusing a minus root 109 is plus root 109, hence why our maximum height is 21.4. So part C, find the time taken to the nearest second from the passengers to reach the maximum height on the second cycle. So think about the cos curve, okay? Think about when it becomes -1. It first becomes -1 at 180 degrees, and then secondly at 540 degrees. So the second cycle is going to be when it equals 540. So it's going to be when cos the bracket is going to be 540. This bracket is going to be 540. So we've got to solve ATT plus 16.69 being 540. Solve that, you get 6.54 minutes. Changing that into minutes and seconds, you get 6 minutes 32 seconds. Now for part D, how would you adapt the equation of the model to reflect the increase in speed? So if you're increasing the speed, it's decided to increase profits, the speed of the wheel is to be increased. So to increase the speed of the wheel, we just need to increase the coefficient of T. So that 80 could become 90, for example. So just anything where you're saying the coefficient of T needs to increase, that will increase the speed.